nice to see you folks. I remember Guillermo from the, was it AMSIS or
AMSIS
San Diego?
Well, I've been to all AMSIS basically, but I organized Cancun and Acapulco.
Those are the ones that nobody remembers because of so much tequila and
Yes.
We still have a lot of people that are still coming in. This is why we always do our small talk at the beginning and all. And we even have here with us today representative of the Middle East and Africa chapter. Is that how you say it, Sam?
Yeah, it is the Middle East and North Africa.
North Africa, all right.
Yeah. Hi, Alex. Hi, Anol. Hi, Guillermo. Hi, everybody.
Hi, Zaza. How are you?
I'm doing well.
We will start trying to do things together with them, and maybe then we have this macro chapter: Latin America, the Caribbean, North of Africa, and the Middle East. And we will conquer the world.
Sam Jazza, right? Is that Sam?
Correct.
Yes.
Oh, okay. So we have interacted at AMSIS recently.
Yes.
I was kind of wondering because your name looks a little different. But yeah.
Yeah, you just need to erase the first 5 letters or something.
Right.
Like that. Yeah,
right.
And then you get it.
So actually, my real name is Ipti Sam.
Right.
Which means the smiling face.
Oh, that goes very well with you. Yeah, absolutely.
And then tell us why you want us to call you just the face instead of the smiling face.
The smiling face, right? So yeah, but for simplicity in the US, for them to pronounce my name, I go by Sam.
So you became just the face or the smile.
Yeah.
The face.
Actually, Ipti Sam is one word.
All right. Okay. So
I go by Guillermo and everybody suffers. So that's okay.
Yeah, that's hard.
all right.
I like to sit and try.
And now Guillermo is imposing himself to the gringos there because now he's the professor there.
Yeah, that's a quite challenge now starting, huh?
Well, I need to hurry before they realize I made a mistake.
Just give you a general stats about the MENASIS, which is the annual conference of the MENA, Middle East and North Africa. So
Let's go.
Yeah, I'm really excited. So the preliminary stats is that we have authors participations from over 20 countries that have never participated in the MENASIS, not even any other affiliated conference for the AIS. So it's kind of, for me, it's like a check. Yay. Most of the authors are actually from the African continent, like Namibia. And I'm sorry if I'm pronouncing wrong the countries.
We understood it.
Namibia, yeah.
Kenya, Ghana, Ethiopia, Morocco, and also the Middle East, Palestine, Lebanon, Saudi Arabia, UAE, and Bahrain. And so for us, this is really great news, not just for the MENA per se, but for the academic community. The goal is, again, the theme of the conference is to bridging the gap between global South, global North, developing countries. The vision that we had to bridge that gap is to bring senior scholars and small capital letters, because that is a distinction, all letters of senior scholars that you can think about, is to actually come in person and participate in the MENASIS, which is going to be held in Agadir, Morocco, November 11th till the 14th. But now we decided it's going to be in hybrid format because of the Delta variant and the whole global situation. But instead of actually bringing physically some of the senior scholars, now I just contacted actually Robert to send a message to the senior scholars to ask them to attend virtually for the presentation sessions, where I hope that these senior scholars will listen to these presentations, provide their expertise, feedback about the topics, and if it's up to them, if they would like to have some sort of mentorship to guide these authors from these underserved region, to walk them through hopefully that successful publication. So saying that, I really invite everybody here to join the conference, and the website for the conference is MENASIS. I hope you can join us, and the sky is the limit. I hope you can interact with the MENA members. Maybe, you never know, some sort of collaboration, exchange ideas, and all of that. And thank you for giving me the time to introduce the MENA.
Oh, you're more than welcome, Sam. And again, we have to think it's not only the South uniting here, but it's really exchanging resources, considering that we have such limited resources. So whenever we can do things together, I think we should try and do that. All right.
Exactly.
And be sure to send us the call whenever you have it ready for the 2022, so that we can actually participate.
Okay,
Send
thank you.
something, right?
So it is, and again, the conference is next month, November 11th till the 14th, 2021 in Agadir, Morocco. I've never been to Morocco, but everybody tells me it's a great country.
Sam, for those who are participating remotely, how does it work? I mean, what are the arrangements to participate? Can you anticipate anything, or it's just?
So far, so we have the registration is attendance is free, but the registration is required. It is hybrid, so you can join us online. We have a lot of panels, panels by the senior editor-in-chief, panels about how to publish, panels about how we are really bridging the gap. And this panel is going to be handled by Michelle Carter and Dr. Boo. And so, yeah, hopefully it's going to be beneficial to elaborate more collaboration between all of us.
Perfect. Thank you very much. Well, before Aurora formally introduces here our speaker of today, Mahi, do you want to do the acknowledgement?
Yes. Thank you, Alexandre. Thank you. I'm sorry, I did some for your talk. I would like to give my welcome to some of our exchange students that are engaging from now until the end of the semester. They are 6, as far as I know. We have 6 new students. They are from. I will try to make the call here, because I think some of them have some problems when they get inside to put their name. I think it's the case of Eric, that is calling Peter, but I know that is Eric because he was already my student. Probably, I think they must put their name when.
I know. People come to our research centers here, and they come disguised. They pretend that they're different people, you know.
Yeah. Yeah, that's it. Well, I have here. I think this one I don't know yet. From India. Abhishek Bidi, are you around? I cannot see you. Please, if you're around,
just say hello if you're there.
Say hello. Probably, well, he's not here. Eric, that is called Peter here, but it's Eric. Hi, Eric.
Hello, everybody.
Welcome. We have Frida and Louise, and I don't see her. I don't know if you have some news from her, Eric. I know that you know each other, but well, Eric is from German, and Louise from Sweden. And Manohna from India. I don't know if you are around. No, I cannot see here in your list, and probably he's not around. And Morten is around. Morten is from Estonia. I see you. Yeah. Hi, Morten.
Hi, everybody. Excited about this.
Thank you for coming. And well, Leonard, that I don't know how to pronounce his name in Chinese. I never know how to pronounce, but he calls it Leonard, but I don't think he is around as well. I don't see in the list. Okay, but probably in the next, if they are not coming today, they will join in the next meetings. And I would like to make my welcome from everybody here. I think, as I explained by email, we have several seminars that are independent from each other related to IS information system topic. So, well, thank you to join us, and welcome to the research seminar.
Great, thank you, Mahi. Well, Aurora, now the floor is yours to present Anol, and so that we finally get to the speaker of the day.
The speaker. Thank you. Well, we want to thank Anol Bhattacherjee, professor, to be with us today in our research seminars that Professor Alexander is coordinating. Professor Anol Bhattacherjee, he's a professor of business analytics and information system and Excite professor at the University of South Florida. He has a 25 years research career. He has published over 100 publications, including 65 reference journal papers and 5 papers in MIS Quarterly, which is the #1 journal in our discipline. He says his papers have been cited over 25,000 times on Google Scholar. Professor Anol's main research topic is algorithm bias, corporate innovations, social media behavior, and healthcare informatics. He has a free textbook of research method, which is a social science research principles, method, and practices, which has been downloaded 1.1 million times from 223 countries, and it has been used by students all universities worldwide.
And I think the first language it was translated to was Arabic, wasn't it, Anol?
I think it was Chinese, but there is an
Chinese.
Arabic
Oh, okay,
version
but
too.
there was some competition there. I was impressed with
Yes, and I know there is not a Spanish version, but Aurora and Guillermo promised there would be a
Yeah,
Spanish
we are
version.
working.
I'm gonna hold you guys
I
to
have,
that.
I have partially done. So
Okay.
I will
that.
be.
I
in the-
wished
Be
I
careful because
Arnaud
that's
did
not
not
Spanish,
remember.
that's Chilean.
I wish Anol did not remember me because I promised him a version in Portuguese. I think we worked a couple of years ago or 3 years ago. We worked on 3 or 4 chapters with some of my students, and then they graduated and we stopped. But now, with the help of Google Scholar, I think this is much better because we don't start from scratch. So there is a possibility that we'll join efforts with people that are here with us today and maybe have
Yeah.
those translations into Spanish and Portuguese. Finally done.
Finally done.
But go on, Aurora.
Okay, so I wanted to add just a couple of things that are very important. Professor Bhattacherjee, he serves as on the editorial board of MIS Quarterly for 4 years and served as an senior editor of the Journal of AIS for 2 years. And he also has the medal, Stafford Beer Medal by the Operational Research Society in the UK, and also was a Pullman Distinguished Chair in 2019. So Professor Anol Bhattacherjee has a PhD and MBA from the University of Houston and a Master of Science and Bachelor degree from the Indian Institute of Technology.
So, well, again, thank you for having me in this session this afternoon. It's a privilege to be in the company of some of the folks that I know from prior meetings. I hope after COVID is over, we'll get a chance to meet again in another conference, perhaps hopefully in another country in South America. So this particular paper that I'm presenting is written with a PhD student of mine. Well, actually, he just became a PhD student just a couple months ago. He joined our PhD program. So he was originally a master's student. And the idea of the project just started this year, January of this year. So I teach a couple of classes in AI in our program in analytics, and one of the classes is text analytics, how to handle text data. So this student was actually a student in my master's class, in the text class. So after the class ended, he kind of said, well, can I continue to work with you on a research project and learn and on that kind of stuff? And I said, yeah, certainly, why not? So we kind of thought about this research project. And so this was a master's student who, and we started this project in January of this year. We wrote up an initial paper, and the paper was accepted in a Destris conference in June that we presented. And then we wrote a second paper, which was kind of an improved version, which was accepted at ISIS. So it's actually scheduled for a presentation at ISIS.
Wow.
So I shared the ISIS version of the paper with you folks. And currently we are working on a journal paper that we'll hopefully submit to one of the top journals in the discipline. So my student, his name is Alysson de Oliveira Silveira. He's from Brazil, really a delightful person to work with. He does most of the work, and I do most of the guiding, so as you can imagine. But it's a sort of one of those interesting projects that is totally outside of my wheelhouse. I've never done anything like this before, but I'm so excited about it. And as you would watch through the presentation, you could see there are plenty of possibilities where this technique might actually help you in your own research. So moving on. So what is it that we are doing here? Well, we have basically created an automated system for coding and storing text data. So this is basically, you think about content analysis that we do in qualitative research. So we created an automated process for doing content analysis on a very large scale. That's essentially what this is. So we build this artifact, and we provide an illustration of the artifact, and we will provide some evaluation of the artifact. So this is a design science project. This is my first design science project. I've never done anything like this before, and I'm pretty sure that I'm not doing it right in many places. And we've gotten some feedback from Destris and ISIS, but obviously they see enough value in it for them to accept it. So let's jump into this project. So what we're going to do is talk about what content analysis is, how it's done, some challenges and opportunities, and then we will discuss the artifact that we designed, the rationale behind the artifact, and the modules, and the underlying technology. And I'm going to give you a presentation, an illustration of how to use it in the case of organizational innovation, specifically looking at trying to understand two concepts in organizational innovation called exploration and exploitation. So we would basically code text data for exploration and exploitation, and we will come out with a number for each of those metrics. And the numbers would be like a number between 1 and 5, like a typical Likert-scaled number. And you can use that number in statistical analysis. So that's really where this paper becomes really interesting. And then I'm going to wrap up with some results and implications. So what is content analysis? Content analysis is the analysis of latent content in a body of communicated materials, such as text documents, a book or a film. through a process of classification, tabulation, evaluation of concepts. So we kind of read through a text and we kind of understand, well, what is author trying to mean, and we kind of code that, and that's sort of this whole process of content analysis. We have been doing content analysis for at least 4 centuries now. Back in the 17th century, the Holy Church was trying to, when they were, sort of trying to figure out, people that they would like to inquisition, based on, documentation available. So they did that a long time ago. It really became more of a formal research method about 100 years ago, in 1927. Political scientist Harold Haswell, he did a study on mass media propaganda. And we basically looked at, text in mass media and tried to identify pieces of propaganda. And that was, one of the early studies in this domain. Today, you will find content analysis is used in media studies, anthropology, psychology, business, information systems. It's a popular technique for textual analysis. So how do we do content analysis? So this is sort of a typical picture of how we do it. So you would have the text data, either in Microsoft Word or in a software like NVivo or Atlas TI, and you would go over the text, and then you would say, well, I think this portion of the text is trying to convey this concept or this idea, and you can sort of code those ideas along the side. So you can see we kind of did some of that in plain Microsoft Word. So we say that the first idea talks about extending the product range. The second idea talks about introducing new generation of products and so forth. So these were like just bits and pieces of the text that I took in. The entire text is way bigger, and it does not have so much information. So this is sort of how we do it. And now 2 different ways of doing content analysis. We could use it in a deductive manner, where we are looking for certain concepts or certain themes or constructs that we know from prior theory or research or literature that we are trying to code for. Or we could use it in an inductive manner, where we would allow the concepts to emerge from the text, and sort of keep an open mind, walk into the coding process without a predefined set of concepts in mind, and just let the text speak for itself and extract those ideas. So those are the 2 ways. Our research is more of the deductive approach, where we know concepts that we are looking for, and then we are trying to code for those known concepts. And secondly, we can also look at content analysis in terms of what is the outcome of the analysis. So sometimes you would see people, they're counting the occurrences of certain words, and that's quantitative. And there is also qualitative analysis based on interpretation of meanings of certain ideas. And then there's obviously a bunch of criticism about the quantitative approach. And a lot of purists who do qualitative research, they say that counting words is not the same as interpreting text. So perhaps we should not be counting things. So we take that into account. So our analysis is qualitative, deductive, but in the end that you will see that we actually come out with a number. So, but the number is not based on how many times certain words appear in a document. The number is based on a different process that I'll talk about a little later. By the way, feel free to jump in at any point in time. If you have questions, just, unmute yourself and ask. So some typical challenges of content analysis. First of all, most of the content analysis that people do, it's manual, and it's extremely laborious and resource intensive. And you cannot analyze thousands of text documents or millions of text documents. It's not possible. If you split it across multiple coders, you will find that each coder codes them differently. They have a different mindset. So, the coding with coder 1 does not match with coding with coder 2, and you will see low inter-coder reliability. So there is no really nice way of coding very large volumes of documents in a manual manner. So essentially, most of the manual coding is done on small samples, perhaps 100 documents or 150 documents at most. And because of the small nature of the sample, you cannot really generalize to a broader population. Other kinds of problems with content analysis is that it tends to work very well with primary data. So for instance, if you go interview a corporate executive and you ask a specific set of questions and they're responding to the questions, and you can do content analysis on that. And it works out very well because you have a very specific set of questions you're asking, about the ideas or the concepts or the constructs you're interested in, and they're responding to that. So the text has a very high level of, signal to noise ratio. Whereas if you look at secondary data like corporate reports or published web articles or something, there's a ton of noise. In all likelihood, they're not talking about anything that you are interested in terms of analysis. So you would see, the signal to noise ratio would be extremely low. And it takes so much time to read through the document, and you get minuscule amounts of information that is really useful. So this process of manual content analysis is not very efficient for coding secondary data. And this is sort of one of the reasons we have one of the sort of a very prominent researcher who works in the domain of cybersecurity. So he said that he and his doctoral student is trying to do some, manual coding of 10K reports, trying to identify cybersecurity flaws. And he wants to code about 4,000 documents. And he says, there is no way I can do this. We can handle this. So he approached me asking if there's a way we could automate that process. And so as I go through the conversation today, you would see there are opportunities where you could actually use this technique in your own research. It's a purely methodology type of article that we are talking about. So that is the manual coding. Now there is some amount of automated coding that is currently being used. There is a software package called LIWC. So essentially all that does is you have to specify a bag of words or a collection of words, and it goes through the document and sees if that word exists. And if it does, it's going to give you a count. It will tell you that word exists so many times. Now, what you could do is instead of specifying one word, you can specify a bag. And the bag would have like synonyms or related words. And it basically counts for the existence of all of those related words and gives you a count. And so that is basically what this lexicon-based approach is. It counts specific words. Now, words is not the same thing as language and meaning, and we'll talk about that. But this approach requires you to specify a lexicon of words. So, for instance, if you want to understand, let's say physicians, resistance towards technology, you have to have words like physician, resistance, technology, hospital, and information systems, information technology, or anything that is related to this domain. You have to specify those words, and it does just a string match, pattern matching. It's not a very efficient way of doing things because there is no way you can specify a complete set of words that might be relevant, particularly when you're looking at social media data and web data. A lot of times people use acronyms, like LOL, and you cannot really anticipate that, oh, maybe I should use LOL in my bag of words. So sometimes it's very hard to figure out. Sometimes people have typographical errors, and you cannot anticipate the range of typographical errors. And therefore, this automated technique does not work very well. So I have some colleagues who use this lexicon-based approach at IWC, and they're constantly struggling, and they're saying, oh, it does not work. So the gold standard of content analysis is still the manual method. And so what we are trying to do is create an automated technique that mirrors, that at least comes close to the manual method. So that's what we're trying to do. Now, if you look at secondary data would be corporate reports, articles on the web. There are some advantages and disadvantages of such data. The opportunities would be, well, they exist in very large volumes and they are growing exponentially. The huge volume may allow us to detect very small effects. So something that is not very common, but you would like to detect, because we have very large volumes, you may be able to detect small effects, or investigate complex relationships, or compare small subsamples and study rare effects that are not visible in small samples. Secondary text corpora is also unbiased by the researchers and their research process. Like, for instance, if you're interviewing people, the interviewer influences the responses. Just to give you an example, I have interviewed doctors, and I had my student Amy went and interviewed doctors when I could not personally attend for some sessions. And the kind of responses that I got from doctors were very different from the kinds of responses that my student Amy got from the same doctors. And so with Amy, the doctors would usually say yes, no. Their answers would be very short, very, very curt. And then with me, they felt more free to discuss, the issues in greater depth. So they would explain why they think certain things happen. And I guess the reason was because I knew them for a very long period of time. And so they trusted me, and they did not know Amy as well. And you would see those kinds of things in qualitative research. The presence of researchers influences, the responses that you get. Even in quantitative research, if they know who is the person who's collecting the data, the presence of the researchers does have an impact. So those are the problems with traditional primary data, but secondary text data does not have those issues because the data was not collected with the explicit purpose of research. So they already exist, right? So we are using it. On the flip side, the challenges are very low signal to noise ratio, makes it infeasible for human coding at very large scales. We talked about typographical errors or acronyms in texts, and particularly if you're trying to analyze social media posts. And that you cannot map clearly to standard lexicons. Like human beings, computers cannot understand ambiguous language. So this is something I'm going to talk about a bit more. So for instance, if you ask, is Apple a fruit or a computer or a company? A word matching technique cannot tell the difference. So that's kind of a problem. If you look at the two sentences, what are you eating and what's eating you, they mean totally different things. The words are exactly the same, but the meaning is entirely different, right? And computers are not good at handling these kinds of meanings. So that's really the problem with matching words. So you cannot say, well, I'm going to match the word eating, right? Because that has totally different meanings here. Or I would match the word apple or something because that's the meaning is different. So that's really the big issue with LIWC or lexicon-based approach. So the inspiration for this study was, Ludwig Wittgenstein, famous German philosopher. He said the meaning of the word is in its use of the language. So, what's eating you in language, it means, what's bothering you, versus what are you eating, that has a totally different meaning. It means that, yeah, physically, what are you eating? Actually, what are you eating for lunch? So it's just the way the word is used in the sentence, in the language. That is what conveys the meaning of the word. It's not the specific word. The word eating does not mean anything, and the word apple does not mean anything. But if you say my apple crashed, then you would know that you are not talking about the company Apple, or you're not talking about the fruit apple, right? Or if you say, well, my apple did not boot, it means something different from if you say, well, I had an apple for lunch. That means something totally different, right? So really, when you look at interpreting languages, we really have to look not at individual words, but look at how words are positioned in a sentence. And that's kind of how we interpret languages. And we are using that philosophy in our research process. And I'm going to give you some examples about how we do that. So just to give you an example, so let's take this very simple exercise. So a question: what is ong choy? Does anyone know what ong choy is? And by the way, if you're Chinese origin, then you cannot say. Some non-Chinese people.
No.
So anyone has any idea what that is? No. All right. Now let me give you some sentences. These are some sentences.
It's not Mandarin, I think.
It is not.
It's not Mandarin. It's Chinese, but not Mandarin.
Violeta,
Okay.
Violeta, maybe it's just slang, and you don't know slang.
I think it's Cantonese. I think it's
Oh, it
Cantonese.
is. Oh, I
Yeah.
see. Okay. I thought it was like bok choy. And obviously many people don't even know what bok choy is, but we do. But anyway, but let me give you some sentences related to ong choy. And here are the sentences. Ong choy sauteed with garlic and served over rice. I loved ong choy and other Chinese salty leafy greens. Ong choy stems and leaves are delicious and goes great with mushroom sauce. Kung Fu Chinese restaurant is famous for its ong choy. So now you have an idea of what ong choy means, right? I haven't
Vegetable.
given you the meaning, but
Edible
you figure it out.
vegetable.
Yeah.
Not eat.
Sounds delicious at least.
Yeah, I mean, so this is how we understand language. So we don't know what ong choy is, but looking at these sentences, we can sort of figure out, oh, it's sort of some kind of a leafy vegetable from China that has leaves and stems, and you kind of saute it and you serve it with rice, and you can get it at a Chinese restaurant. So you kind of get this idea. Obviously, if I show you a picture, it's gonna really cement what ong choy is. It's basically this particular dish that you're looking at. So obviously, a picture is worth 1,000 words. But then, if you want to understand the meaning of words, well, we use words in different ways. So, if you say, yeah, I'm going to the bank to withdraw cash, versus if you say, well, he went to the river bank to fish, well, the word bank means very different. And then if I say, well, Alexandria, I'm banking on you to deliver me the report on Friday, well, that's a totally different bank, right? So again, the word bank has different meaning depending on the context in which it's used. And the way human beings, we understand meanings of words is within that context. So the same word could be reused in totally different contexts and have entirely different meaning. And that's really the point of this whole exercise. So how do we capture the meaning of words as it's used in the language? Because that seems to me, that is really the essence of qualitative coding. Now, when we are reading this qualitative text, we understand what the author is trying to say, right? And we kind of say, well, yeah, they are talking about, corporate culture, or they're talking about a problem happening in their organization. And we make sense out of this. But computers cannot. And certainly, looking at words and counting words is not a way to do that. That's currently how we are doing it right now. So is there a better way to do that reflects the way human beings, we process technology, right? And that is essentially what AI is. If you look at the history of AI, the original goal of artificial intelligence was, can we have a computer do things that a human being normally does? And so the original idea of the Turing test is, if you could not tell whether you're interacting with a computer or a human being, then we know that the machine has passed the Turing test. That was the original idea of AI. So AI was designed, not for business data processing or anything. It was designed for doing human tasks that you cannot tell that there was a human on the other side. And so what is a classic human task? Well, it's natural language processing. It's understanding languages. And for a long period of time in AI space, we had no idea how to do that. And then we had a sort of, the original, when computers were designed, the original objective of computer programming was to understand human languages. And then for a period of time, we kind of, we gave up, we kind of lost focus, and we didn't make much progress in understanding NLP. So even though, these courses were being taught in the computer science program, as a research discipline, we did not make much progress until, the year 2005, 2006 or so, until Google came into play. and Google started crawling web pages and creating an index and gave you the opportunity to do search on Google. And that is sort of where Google started to explore, how do I understand languages? How do I understand what people are trying to search about? How do I understand people's preferences and use that to monetize that with ads and so forth? And so we are kind of headed in that direction now. So we had a spring, we had a winter of AI, and now we are back in the spring of AI. We're trying to see, can we understand human languages better? And you can see computers are getting better and better at that. So all these Google Translate, there was a point in time when we would laugh and say, well, this translation makes no sense, right? But you would notice Google Translate is getting better. So now English to Spanish, English to Mandarin translation, they actually make sense. And it's getting improved, it's getting better. Not just language translations, things like you must have heard about, GPT-3. It's a technology that creates text. Like you tell him, write a paper on the American Civil War, and it's going to write a paper on American Civil War, like a complete, text with paragraphs and complete sentences. So these are the kinds of things humans do, right?
In Portuguese, someone even wrote these codes this program that they had online, that was a translation would be generator of bullshit. Exactly. Language, but the thing was, you just include some clever words there, and it was in fact to fool the teachers. You just include the words that you think that are important and that relate to the topic, and then it generates this beautiful text that says nothing, but at the same time impresses people.
Yeah, some of those initial experiments resulted mostly in garbage text, but now if you Google GPT-3 and look at how this model is doing computer generated text, you would be shocked. It will literally shock you about how good computer text generation has become. Another classic case where we work with text as human beings is we read a lot of papers and we create summaries like literature reviews and stuff. Again, can you get a computer to do that, right? Again, that's a classic use case of text, natural language processing, text summarization. It requires the computer to understand what is it that I'm reading and how I can summarize it. Again, so we've gone through a lot of hiccups, and we are getting better. So a lot of these things that is sort of traditionally human, like understanding text, summarizing text, generating text, now computers are getting smarter and smarter. So you would see a lot of interesting things happening in this space over the next few years. So in terms of what we are actually doing, well, there's a very sophisticated design architecture that I will just briefly go through. I don't want to bore you too much with the details, but essentially what we are doing is so you feed in a text corpus. So on the left side of this picture there are 3 white boxes. These are inputs into this algorithm. On the right side of the picture, there's one white box called construct scores. That's the output of this algorithm. So what do we do? What do we feed in this algorithm are 3 things. First, we feed in the text corpus. The text corpus is the qualitative text that we want to code. Second, what we feed in a set of operationalized construct measures. So an example would be, let's say I want to measure culture, organizational culture. So I'm going to go look into some survey instruments that measure organizational culture or trust or any construct. So we would see what kind of items were used to measure culture. So I'm going to feed in those items into my design process. And then what this algorithm will do, it will look at similarity between the text that I fed in and the constructs that I fed in, and it's going to compute the similarity score, and that is called the cosine similarity. And based on the cosine similarity score, it's going to then classify whether the text that you passed in belongs to that construct or does not belong to that construct. It's just a binary classification, yes or no type thing. Now, there's a whole process that we go through. Now, how do you look at similarity between the 2 texts, right? Similarity in meaning, semantic meaning I'm talking about, and not similarity in terms of words. So what we do is we use a pre-trained transformer model. This is a deep learning model that is generated by Google. And then there are many others like Microsoft and others. They're all building their transformer models. So essentially these transformer models are deep learning architectures models that are designed to understand text. And then these things are being used by computers to generate text, to summarize text, to do pretty much all the kinds of text processing that we talked about. So these transformer models are things that were developed over the last couple of years. So, I think the first transformer model came out in the year 2019. That was right before COVID, right? So this is brand new stuff. What we're talking about was developed over the last couple of years. And some of the models that we are using in our paper were designed over the last year or so. So they are brand new. They are not used. Most people don't even understand what these things are or how they should be used. Now, being a technology person myself, and since I teach this class, I took the pains of trying to learn and so forth. So the process that we go through is we take the text corpus, the text document, and then we do some pre-processing on the text document. The pre-processing include things like, converting all the text into lowercase and, dropping punctuations and doing some preliminary, cleaning, and then tokenizing them into sentences. So we take an entire document, we split it into sentences, And then we compare each sentence with the construct item, which is also a sentence. So we compare the two sentences in terms of the semantic closeness. We do something called a named entity replacement. Well, that was something that we added later on. We noticed that our algorithms sometimes cannot detect the fact that if you have a name of a product, so if you have a product like iPhone 11 Pro, it does not quite understand that that is the name of a product. It just reads it as iPhone 11 Pro. So what we did was we kind of changed that iPhone 11 Pro into sort of product. We changed it into the word product. That's this named entity replacement. So we identified certain named entities and we replaced them with words that the computer would understand. And then what we do is we convert that each sentence into what we call a sentence embedding, which is basically a vector representation of a sentence. So so the sentence is converted into a vector that has about 768 items. It's a vector of numbers. And so we have a vector for the sentences, we have a vector for the construct measures, and we can then look at the similarity between the two vectors. It's just dot matrix of vectors, and there are simple formulas for computing cosine similarity scores. It's a distance between the two vectors, Euclidean distance, and that's pretty much it. Now, based on how close, how high or how low the similarity is, so that's the threshold. So if it exceeds a certain level, then we say, well, we agree, we think that this sentence represents this construct. If it's lower than that threshold level, then we say, well, I don't think the sentence represents that construct. So that is sort of this cosine similarity threshold, and using that, we create construct scores. So if you're interested, you read the paper, or get back with me if you're interested in the design architecture. But I don't want to bore you too much about that. So let's talk a little bit about this sentence transformer, and we move on to the actual application. So sentence transformer are pre-trained deep learning models that uses something called an encoder-decoder architecture to transform an input sequence into a different output sequence. So an input sequence could be, let's say, a text in English. An output sentence could be text in Chinese or text in Spanish. And so this encoder-decoder architecture is used for language translation. Similarly, this encoder-decoder architecture is also used for text summarization. So you can feed in 10,000 word text, and you say, well, the output I want to be is like 100 word text, right? So it takes this input text, it converts it into this output text. What we are doing here in this case is actually quite similar. What we are feeding in is two pairs of sentences, and what comes out, the output is a cosine similarity score. It's a number. And then we use that number to classify, those algorithms. So typically, the sentence transformers are used for machine translation, next word prediction. There's a variety of use cases that, chatbots, summarization, etc. So there are many such transformer architectures that are available. The first transformer architecture was designed by Google's AI lab in 2019. It's called BERT, bidirectional encoder representation from transformer. That was the original model, and since then there has been some improvements to the model. So Facebook came out with a retrained version of BERT, which is called Roberta, and it was trained with a lot of like 1,000% more data, and it has significant performance improvement. And then there was a distilled BERT that used Bayesian technique to improve, accuracy and improve speed and accuracy. Then there is something called Roberta, S-Roberta, which is fine-tuning of the Roberta model to reduce computational time. So we use S-Roberta in our analysis. There is a brand new model came out from Microsoft, just a few months ago. That's called the MPNet, which is again the Microsoft, language model, optimized for efficiency. And then there's, SimCSE, which is also pretty new, came from Princeton University. So our paper was originally done using Roberta, but then we kind of wanted to see how Roberta compares with other language models. So we also tested against MPNet and SimCSE. All right, so application. So this is what we are trying to do. So the domain of this work is organizational innovations. Now, if you look at the literature in innovations, there are two kinds of ways companies innovate, and they're called exploration and exploitation. So exploration is the process of discovering new products, new resources, new knowledge, new opportunities. Whereas exploitation is the strategy of utilizing existing products better, utilizing existing resources, utilizing existing knowledge, existing competency. And the goal here is to reduce the cost of production or to improve efficiency. Versus in exploration, the goal is to discover new products and new markets and new opportunities. So the focus of the two innovation strategies is quite different. Exploration is, tries to, look for, things that can generate future revenue streams, whereas exploitation tries to look for things that can improve existing revenue streams. Like, for instance, going from Apple, iPhone 10 to iPhone 11, that would be exploitation. Whereas going from iPhone to a completely different product, that would be more of an exploration. Now you might say, well, should companies do exploration or should they do exploitation or both? That's kind of the big, question in strategic management in innovation research. So exploration requires risk taking. It requires experimentation, improvisations, radical changes, chaos. Sometimes exploration is called radical innovation, and exploitation is called incremental innovation. And you look at what do we need in order to do incremental innovation? Well, we want to avoid risks. We want to refine incrementally. We want to focus on efficiency, stability, and order. So we don't want chaos. We don't want like wild experimentation. We want to contain that process. So, the philosophy of these two kinds of innovation processes are very, very different. That's the point I'm trying to sort of elaborate here. So exploration requires organic structures, like free minded experimentation, a lot of autonomy, a lot of chaos, loosely coupled systems. It requires you to break new grounds, whereas exploitation requires mechanistic structures, tightly coupled system, controlled bureaucracy, stable markets, stable technology. So that's kind of the difference. So you would find that companies, you would say which is more important. And, I usually get all kinds of reactions from people. A lot of people think that exploration is important, but then, you need cash flow, you need revenue stream to explore, right? And the cash flow comes from exploitation. So companies that exploit existing technologies, they're also the same companies that can explore. They got the resources. Obviously, startups, they focus more on exploration. But then, if they just, explore and they never get to the point of exploitation, they're not going to be surviving over the long term. So that's sort of the dilemma. So a common philosophy in strategic management is companies that can do both at the same time, exploration and exploitation. They are the most successful companies in terms of innovation, more successful than companies that either do exploration or do exploitation, but folks who can do both. And these are called the ambidextrous organizations. So there's a whole bunch of research on ambidextrity hypotheses, which essentially means that doing both is better than doing one or the other. So how do we measure exploration and exploitation? That's really what we are trying to do from this textual analysis. So one way of measuring is by interviewing chief executive officers and so forth, chief executives. Access might be difficult, getting these executives to talk to you. There may be response bias. If you go and ask them questions, they're gonna say things that will portray them in a positive light. So the word exploitation generally connotes a negative connotation. So they would say, no, we don't exploit. But that's not the same exploitation we are talking about here. We are not talking about exploiting poor people or anything. Exploiting is exploiting resources and exploiting existing innovation streams. You could also use surveys. Surveys is actually traditionally the most dominant way of doing these types of research. So there are standard, validated survey instruments. Surveys are obviously going to be cross-sectional surveys, and you can survey companies on their exploration activities, their exploitation activities, and so forth. There's some problems with survey research. Response rates are very low, so a lot of companies do not respond. Social desirability bias, which basically means that survey questions, you don't quite get the responses you're looking for. Sometimes they would just say positive things, even though it's incorrect. And then there is this huge common method bias in surveys, which is essentially like if you survey, use your survey instrument to capture independent and dependent variable, they're correlated, and that's the bias, and that bias is your output. Another approach might be to look at secondary documents, secondary data, and see if you can qualitatively code them, and that is the approach that we are taking in this study. So can we code pre-existing corporate documentation for exploration and exploitation constructs using validated survey instruments that we already know that exist from survey research? So that's kind of what we are trying to do. So here's an example of a survey instrument. So this particular instrument is taken from the paper Hay and Wong, 2004. It asks corporate executives to say, well, what are your objectives for undertaking innovation projects over the last 3 years? So rate your objective from 1, which is not important, to 5, which is very important. And then it asks these questions: introduce new generation of products. How important was that? Extending product ranges, open up new markets, enter new technology fields, and then improve existing product quality, improve production flexibility, reduce production cost, improve yield. So you can see the last 4 items are about improving existing things. So that's about exploitation. And then the first 4 items are about exploration, new products, new markets, new technology, etc. So those are sort of those 4-item measures that this particular paper used for exploration versus exploitation. And so what we are doing is we are actually using these metrics, these measures. So we are using this as a way, and we're trying to match these sentences, these fragments of sentences with words in a corporate document to see, what degree of match we have. And so what we did was we sourced data from the SEC Edgar website. We selected firms that filed 10K reports for the year 2020. So we tried to get 5 years worth of data. We did some random sampling. So eventually, I think we ended up with having 134 firms for 5 years. We have 670 observations total from 2016 to 2020. And this is sort of the industry distribution of companies. So to evaluate how good or how poor a job we were doing, we did some manual coding, sort of as a ground truth to compare our analysis. So we randomly sampled 20 10K reports over the 5-year period, and we manually coded them for exploration and exploitation. And then what we did was we tried to use that as a way to compare our coding with what the computer was generating in terms of similarity scores. And we use that comparison to sort of optimize what would be a good threshold. Usually you will find a lot of our AI algorithms, they use, they estimate a probability of occurrence and they use 0.50 as the threshold, meaning higher than 0.50, we say yes, and true case, and less than 0.50 is false case. But that 0.50 may not necessarily be a good threshold, because particularly with text documents, like 10K reports, I don't know if you have seen it. Some of these reports go like hundreds of pages long. I was looking at Pfizer's 10K report last quarter. Hundreds of pages long, and they may mention like 1 or 2 sentences somewhere in the document that even mention innovations or exploration or exploitation. Clearly, we know that Pfizer was doing some exploitation. They created the coronavirus vaccine, right? So that was an example of exploitation. But then where do you find it within that huge jungle of 100 pages of text, which talks about so many other issues that have nothing to do with exploration? So that was really sort of what we're trying to do. So what we did was, using our sort of sample data, or manually, coded data, we tried to, plot, recall, precision, F1 score graphs, and we tried to figure out what would be the optimum point. And so the optimum points, you can see it's a little different from each of these, these categories. There are 4 categories of exploration and 4 categories for exploitation. And it's not like 0.5 in each case, and I'll talk about that in a second. So this was the optimum category that we found. So we use this optimum category, which is the highest F1 score to code, to compare our coding with an automated coding. So this is our optimum. We also compare it against sort of a fixed, threshold of 0.50, which is, popular. And we also kind of did it with, we looked at the mean cosine similarity plus minus U sigma, assuming that, the similarity follows a normal distribution, which it didn't. But we thought let's look at a normally distributed plot. So we did 3 ways of doing it, and I think the number to look at is here. Macro F1 is what we found is 0.62. Our algorithm generated 0.62 compared to 0.54 and 0.59 for the other approaches. We also compared our analysis with, I mentioned this NER, named entity recognition. So we replaced the word iPad Pro with the word product. So we replace the word AirPods Pro with product, because we are looking for items. Like if you go look into this, this questionnaire, they say introduce new generation of products, right? Now, the computers are not smart enough to recognize that iPad Pro is a product. That was a problem that we are having. So what we did was we changed iPad Pro into the word product. So then we could see sort of a match, how it worked. And that was the NER algorithm. So we tried that. And with NER, we could see significant improvement in cosine similarity, without NER versus with NER. We did the same process. We ran 3 different models for robustness check. So our original analysis was S-Roberta. We compared that with MPNet and SIM-CSE, and you can look at the macro F1 scores. Our approach with NER generated 0.61 versus 0.60 for MPNet and SIM-CSE. This is with NER. Without NER, we also had 0.61. So I guess NER didn't really make a lot of difference in the overall scale of things, but that's sort of we are experimenting, trying to figure out what would be a good way of doing this. All right, so for individually for each of the 8 categories, so there were 4 items for exploration and 4 items for exploitation. So how did our model perform with respect to each of those items? And so you can see our cosine similarity scores and standard deviations for each of the 3 models, with and without NER analysis. And you can see there are certain items that did pretty well. Like item number 1, you can see consistently high levels of cosine similarity. And you compare against item number 8, the very last column, you can see low levels of cosine similarity. So obviously our approach worked better with some of these matching of items, and it did not work well with some of the other items. For instance, item number 8 was improving yield, material yield, and it didn't seem like the 10K reports really talked about improving material yield. That was something that never came up. And so what we found was the score was relatively low because you couldn't find a match. Anyway, so that was enough of the boring stuff and technical jargon and all that. So let's see what did we find. So this is, we had 670 observations. We had 134 companies that we analyzed over a 5-year period. So how do these companies stack up? So this is sort of this graph on the right side tells you, so we plotted exploration versus exploitation. So there are some companies that got 1 on exploration and 1 on exploitation. So how did we get to this 1, 2, 3, 4, 5? Well, essentially what we did was, let me go back to the previous slide. So the first 4 items were exploration, the last 4 items were exploitation. So what we did was, if this item was categorized as 1 versus 0, So each of those items were 1 versus 0, classification algorithm. So we counted the number of ones. So the number of ones would go between 0 to 4, right? If all 4 items were 1 versus if all 4 items were 0. So you have a score that goes between 0 and 4. And so what we did is we just added, those 4 items for exploration and the 4 items for exploitation. And then we added 1 to that. So we have a nice scale that goes between 1 to 5. It looks like a Likert scale. It's a categorical scale. So, and that is what we are mapping right here. So we have the 1 to 5 rating. 1 is, poor, 5 is high. So there is a bunch of companies here that are low on exploration and exploitation. There are some companies that are high on exploration and exploitation. There are some companies that are better at exploration than at exploitation, and vice versa. So, we had a very nice sort of a visual and a quantitative analysis of exploration and exploitation of the companies in our sample. Just by text mining, their 10K reports that they have, filed with Securities and Exchange Commission. Now we looked at, since we had 5 years of data, we kind of plotted them, the exploration and exploitation scores over, year over year. So 2016 through 2018, you would see there are some interesting trends. The trends is like exploitation is increasing in the United States and exploration is dropping. So we saw that pattern. And then something happened in the year 2018, 2019. Any idea what happened? It seemed like both of them.
Yeah.
Well, what happened was COVID.
Yeah.
So COVID happened, all the companies went into a work from home sort of an arrangement. So I guess innovation went down because innovation requires an open culture, right? You have to interact with people. So I think a lot of that went down. And you could see in the 2019 fiscal year, innovation dropped for both exploration and exploitation. And from 2019 to 2020, since the company started opening, both of them are sort of getting better, but that's sort of, it's trying to catch up. But so COVID is a very unique situation. I don't think we can really analyze the COVID data. But if you look at what happened before COVID, we had 3 years of data. I think it's kind of probably not particularly surprising that companies are exploring less and less and exploiting more and more. Yeah, and I guess that's probably because of business pressures and so forth. All right, so some contributions of our paper. What did we learn through this whole process? So the methodological contribution is that we designed and validated an artifact for content analysis of text documents. So this artifact obviously didn't exist. There was no mechanism of scoring. Even if you did content analysis, you could say, well, company A is exploring or not exploring, company B is exploiting or not exploiting. But there was no mechanism of computing a score between 1 to 5. And that's really what this value-added contribution of this article is. We extended content analysis to scoring documents on predefined constructs of interest. Now you can apply this technique to a variety of other situations. So let's say you do research in cybersecurity, and you say, well, I want an automated coding process that looks at the 10K reports and gives me a score. How well the company has in terms of internal controls. What is the strength of internal controls? What is the propensity to cybersecurity risks and so forth. Well, you can now there's a mechanism of computing scores. And you can use these numbers in statistical models, for regression, type analysis. So this is a very unique paper that sort of, not only addresses a very perennial problem in qualitative research, like how do I code very large volumes of text without human intervention, but takes it one step further. And it says, well, how do I code it and create a number out of this? And then I can use it with other numbers, right? So I can compare, internal controls against, let's say, revenue growth or earnings or some other financial metric. And we can see, if the corporate policies that we are doing, does it have an impact on the financial health of a company. So those are now possibilities that we have. So this is sort of a opportunity where we are using big data, but not big numeric data. We are using big text data for qualitative research, and we are using it, in conjunction with survey instruments that we know from quantitative research, and we are using it in a way that allows us to do mixed mode research in sort of techniques that were not possible before. The theoretical contribution of the paper is now we have 5-year longitudinal profiles of 134 firms in a sample. So that will help us understand innovation trajectories. Like how did innovation proceed in each of these companies? Did it increase? Did it decrease? So I talked a little bit about the trajectory in that graph, with year across year, so you can kind of get a sense of that. But you could do analysis by individual companies. You can do analysis by sectors, industry sectors. You could compare company A against company B. So you can benchmark companies against each other, and which can help us understand paths and trajectories. And these are things that innovation researchers have talked about in the past. March is one of those, seminal authors, and he mentioned that organizations go through paths. And so, whether you're exploring or exploiting next year is a function of what did you do last year and year before, and what is your culture and that type of thing. And historically, we never had an opportunity to study these kinds of things because we don't have multi-year data, right? I mean, mostly if you do a survey research, you'll get a snapshot of what's going on in the company right now. But doing any kind of temporal analysis requires multi-year data. But now we have a mechanism where we actually can collect data over 5 years or 10-year period, and we can kind of compute a time, panel. We can create panel data that we could feed into sort of temporal data analysis, panel data models. I'm sorry, excuse me. Let me turn this off. Okay, so practical contribution. We created a metric for corporate innovation that financial analysts, shareholders, and investors could use. I mean, obviously, one of the big things that investors look for is that they want to find out how innovative is a company. How can I measure the innovativeness, right? And today, there is no such metric for innovativeness. And how do you know Google is innovative on a scale of 5, it gets a 5, and Yahoo gets a score of 3? How would you do that? Right? So there is no metric for that. But now we have a metric. So I think it has some real practical business value as well. And we could use it for creating innovation scorecards for companies. We can benchmark, firm innovation against the industry's peer. We could look at sector-wide innovations, and I mean, there's so much possibilities. And so, I was really excited when this research sort of ended. The novelty of the research is we use design science approach, artifact construction and evaluation as a way of bridging qualitative and quantitative research. The quantitative pieces, we got survey instruments from quantitative research, and we are using those survey items to do content analysis with qualitative data. So it kind of brings together many of the pieces in IS research that we commonly, we look at design science and qualitative and quantitative separately, but what happens if you bring them together? And that's really what this research project is about. It was like, combining things and looking at what kind of possibilities that can be generated. And it uses, what it leverages what we already know from survey research. We have done so much of survey research on innovation. So we are leveraging their instrumentation, and we are using that knowledge to inform our coding process. And we are training our computers to do the coding. So computers, we are not just saying, well, go, code on exploration and exploitation, because that makes no sense. Those two words, it doesn't mean anything. But then what I'm doing is I'm telling the computers, well, look for things that kind of say that the company is building new products. That's like one item. Look for things that say that the company is entering new markets. Well, that's another item for exploration. Or look for ways that says that the company is trying to improve an existing product or a product line. Well, that's an exploitation item. So I'm kind of telling the computer to look for certain things, and it uses the semantic text similarity architecture to look at meaning, and that semantic comparison is what you get from the sentence transformer model. That's what these Google guys are doing, and we are just using their technology for doing this. So this was sort of and lastly, I'm gonna just put in a shameless plug for my book. If you guys have never seen this book, you should definitely use it. It's used in 225 countries, 7 languages, 22,000 institutions use it. And this is the number that will blow your mind. It's currently has been downloaded 1.1 million times. And this is the place where you can download this book from. Or if you don't know, just Google social science research, and you'll get to this download page. These are the countries where it's downloaded from. The United States, 227,000 downloads, followed by India, and then Philippines, United Kingdom, Canada. The institutions that use this book, all the top schools: Oxford, Cambridge, Harvard, UPenn, Washington, Toronto, Sydney. I mean, this is just a partial list. I've noticed that the US Army also uses this textbook. The US Army Information Systems Command uses it. DoD Network Research Center uses it. I have seen that the government of South Africa uses it. And there are some, national, research networks in Sri Lanka and other countries that also use it, which is kind of interesting. But that was just a plug.
And it's not even in Spanish.
And yeah, and these downloads that you see, this is just the English language downloads.
Yeah.
Because I don't track any other language downloads, and it's downloads only from this one particular website, the USF Commons website. Now I know that the book it's a Creative Commons book, so it has been hosted at other websites. So I don't really count any of those other websites. So this is a very conservative count. I think the book is probably used a lot more than what you see. This is like one website, only the English language downloads. And I'm anticipating that I'm going to come out with a new version of the book, in quite soon. Just as soon as I can wrap up some of my research project and I can create some free time, I would like to create this. I'm already started working on the second version of the book. So this would be like a 10-year update of the first book. It's not 10 years yet since it came out, but I'm planning to do a 10-year update version. A new version would be significantly improved. It will have new research methods, new approaches. It will have mixed mode research. It will have a lot of the things that I'm currently doing that were not there 10 years ago. So yeah, look forward to the 10-year update. It's probably going to come up sometime early next year. And in addition to the textbook, you would see that I have some exciting plans for this book as well. I'm planning to create a YouTube channel where I'm going to have short videos where I will interview other professors, and I will ask them questions on how do you suggest that PhD students should go look for research ideas? That kind of questions that the students have in mind, or how should I read a paper? So I'll present my own ideas and opinions, but I'll also interview other professors, so you can kind of see, what people think about it. And I think hopefully it will be a great resource, free resource for anyone, particularly who don't have access to a world-class program, and they can see, how people think. And I'm thinking perhaps I could also do some papers, pick up some papers, do sort of like tear down, do some post-mortem analysis, look at how things could have been done better, or how things could have been done differently, that type of analysis. So yeah, look forward to a YouTube or website that is coming down the road. And that is all my discussion. I'm not sure how long I had for the time that was allocated. Probably went over the time limit. Apologize for that. But I would be happy to take any questions.
Anol, can you show me the previous slide with the picture of the book?
Right there.
Right here.
Now there is also
maybe I know what you could do is also you could just include the link in our chat.
Okay.
That will make it easier for people to reach it.
Right. What I will do is I will share the slides with Aurora or Alexandra, and you can share it with you. And this is right here. This is the link right there. You can get it. And I'll send you the link as well in an email.
Pepe was faster than any one of us.
Yeah.
The link is already there in our chat as well.
Oh,
Yeah, I see. Someone put it already. Place it.
But if you send us the slides, we will include. We have a Moodle area where we have here many professors from Latin America here with us today, and we also have many students, graduate students, and we have a Moodle platform in which we include all the material that our speakers bring to us. And now, considering that you're already, let's say, sold to Google technology, I would challenge you to consider having your book. I think the previous version was in Word, right?
Yeah, it's a PDF version. Yeah, exactly.
Yeah, it was a PDF. But I think you shared it with us a few years ago at that Confirm, where Aurora and I committed and never fulfilled our promise to translate it to Spanish and Portuguese. I think you
I was only a witness.
Yeah, I know.
No, Guillermo, you promised you'll help Aurora with the Spanish version.
But Aurora has not left me. She doesn't leave me. She doesn't let me do it.
But my suggestion would be maybe you could try and have a version of the book in Google Drive or Google Docs, because Google Docs now has a feature that it allows you to translate the whole document to different languages. And again, it's improving each time. It's better. I have already done that with students of mine. We write a paper in Portuguese now. We have it translated to English, and then of course we have to brush it for the language. But it's still much better than starting from scratch. And that may be a way of improving our capacity of work, of helping you with those translations. It's an attempt, but I think it would be, maybe it's a technology that will prove very good in that sense. The same way as, YouTube is proving very amazing in including subtitles in the original language of a talk, and then allowing you to convert it to other languages very easily and with a good level of quality already.
Yes, certainly. Well, any other questions or comments you have about the research that I presented?
I know. How do you handle the cycles for the design science approach? Were you kind of fine-tuning the algorithm?
No,
kind of counting the hit ratio, or what were you doing in that sense?
So the way it started is, first of all, I know nothing about design science research. So I claim total ignorance, right? Even though Al Hefner, his office is like 3 doors down from my office. But they talk about the cycle and the design theory and all of that, and none of that actually is there in this document. This all started just as an exercise. If you recall, this was a student who wanted to learn about sentence transformers, and I said, well, yeah, if you're learning, let me do something that's going to help me down the road. And I really want to code, textual document, and I want to do an automated way of coding. That was how it started. So it started with a very practical problem. It's a personal problem. How do I code documents, right? That was the origin. I didn't really start with the mindset of, well, I want to build a design science artifact and I need to follow this path and all. See, that I didn't go with that approach. So and now I'm sort of realizing that maybe I should have considered that, because if you try to publish this, now you run into these issues, because reviewers will say, oh, did you follow the design science life cycle? Well, maybe I didn't. But following the life cycle, I don't think that necessarily leads to a better product, right?
Right.
So yeah, I have some mixed feelings about design science. I think these people just shot themselves in the foot. They should really focus on building things that work. So if you think about like Google built its huge, application, its web server. You go ask Google, did it follow the design science life cycle? Google said, of course not. But we know that our search engine works, right? And that should be the proof of the pudding. Does it work? Does it work well, right? So I would encourage people to try this approach, apply it to other domains. We did for exploration and exploitation. So if it works in other domains, if it works, I think it could be a commercial product, if you will. Even though we didn't follow the design science life cycle, I don't care too much about what theoreticians talk about.
We were hoping you would have that in Creative Commons as well, and we can get access to the artifact.
Sorry, I'm complete ignorance. First of all, I don't know nothing about those design science things. I have a lot of friends who do design science research, but that's the extent of my knowledge.
No, but I meant the artifact, that if we got access to it.
Right.
Being at the university where you are, we would expect you to, because
no, I know that. Yes, I know that, and I'm part of the conference committee for next year's DESRIS.
Right.
So yeah, you would expect that someone like me should know something about design science. But yeah, I'm here to tell you, no, I know nothing about design science. Yeah, my background is mostly quantitative research. So that's where I come from. And I've dabbled a little bit on qualitative research, not a whole lot, but I've done some interviews and coding and all that. So I understand the problems of qualitative research. This whole algorithm is fairly recent. This is when our university decided that we're going to start a business analytics program and we'll start teaching these classes. And I said, yeah, I'm volunteering. I would like to teach some of these new classes that I know nothing about, but it will be exciting to learn. And so now I've learned something about Google models and Facebook models and NLP algorithms, and I'm constantly learning new stuff and I'm teaching. So I'm kind of trying to use what I'm teaching for my own purpose, for my research, right? So that's where we are right now. So yeah, even if you don't get methodology papers, I think we can probably use this for in a variety of contexts. We could use it for like a paper for exploration and exploitation. We are working on that, and we can probably publish a paper on cybersecurity using this technique, using this approach. So I think in the domain we could make quite a bit of contribution, even though we didn't follow the design science cycle, and we didn't dot the I's, we did not cross the T's, we did not follow their path. We did our own path. I think we should be allowed to do our own thing. Historically, if you look at the waterfall life cycle, well, that was a model. But if you look today, no one follows that. They use something else called agile method, right? So I don't think there is anything sacrosanct about the design science life cycle. This is just a model that Al Havner said, and we should be willing and able to toss this apart and throw it out and use our own approach if our approach works better. That's just my way of looking at it.
Or adapt it, right?
Or adapt it, certainly. So I think our approach would be more like agile. We have a problem, we're trying to deliver, we're trying to improve. Maybe that should be my explanation, that we are using an agile approach rather than a waterfall approach.
That sounds good. I have a question, Anol.
Yes, please.
I found the methodology like a very, opened my mind to thinking, what is a content analysis? Is already a qualitative still? It's going to be a quantitative in the future if we go this path, probably. Huh? Because
that's but it's a different kind of quantitative analysis. So if you look at the classification models, we are still saying, well, this company is producing new product or not producing new product. That's qualitative. That's a binary. But then what we have these 4 items, right? 4 items that measure exploration, and then we can add up those 4 items and we can create this 1 to 5 numeric scale. Now I don't know how good or bad this scale is, and obviously you can add more items and you can probably get a finer grained scales. Yeah, but one of the issues that I have struggled with is, how do I combine qualitative and quantitative research? That's something that I personally dealt with, because I myself, being a quantitative person, and I'm familiar with statistical models and all that. How do I integrate that with text or content analysis? So I have now a method that allows me to do so. Now, is this good? Is this bad? Will it work? I have no idea. I just know that we started this project in January, and by July we have an ISIS paper written with a student who hadn't yet joined a PhD program. He was just a master's student. So I think that was pretty remarkable. Well, he joined our PhD program in August after the paper was accepted at ISIS. So that was quite interesting. So,
that's a good omen. That's a good omen.
And we are working on a couple of journal papers, and he just joined the program first semester, right? So, and he's very hardworking. He's this Brazilian guy I mentioned, right? Super hardworking. He understands. I'm so delighted to have such a Brazilian student in my, working with me, and it's a delight and a pleasure. And if I can write a couple of papers with him in his first year, I think that's going to help him down the road. So that's sort of the idea. And if people, younger people are interested in exploring new ventures and trying new technologies and things like that, if you want to explore the space, if you have any interest, reach out to me. I would be delighted to work with you. You kind of have an idea of what this, tool does. Obviously, you can use the same method for content analysis in other contexts, right? You can use the same method. So if you think there is such a context where we could, mine data, and I can probably help you with those kinds of work. You don't have to understand the technology or anything, because we got the methodology worked out. It's not a very simple tool or anything, though. it still requires a lot of parallel processing and Python programming. There's a lot of technical elements to this, right? So it's not like a packaged software.
Yeah, and this is how far is this from being part of a software like NVivo or Atlas
I
AI?
don't know. Frankly speaking, I don't know, and I don't even care.
Okay.
See, this is the problem. There is no need for me to sell this software. It's not like a COVID vaccine that I'll plan to make a lot of money from. No,
Don't sell it. We want it free.
no, I'm giving it. Yeah, that is my point.
That's good.
If you do something well, just share it with the world. That was my approach with the book, right? And so this paper is basically describing what we did. And so if anyone wants to do it, hey, just follow our algorithm, maybe figure out ways in which you can do it better, right? And so we describe the process. There is nothing patented about any of this. It's all open. That is the reason why we do research. If I were to market it, then I would not write a paper, and I would probably focus on creating the software and try to sell it, right?
And now, when you were reflecting about the use you made of, it seems that now it's my phone that is ringing here. When you made your reflection on the use that you did of design science research, and you said, well, we used it the way it was convenient to us. I always, and considering that we have many students here among us, in fact, methodology and our methodological procedures should always be something that makes sense to us. And then, of course, we also think that will make sense to our readers, to those that will be assessing the quality of our work, regardless of if they are let's say, the gatekeepers that will, allow or prevent us from being published, or the readers that read it, let's say, in a more open way later on, but that will still have to be convinced by your method. So
right.
I would say that maybe the reason to use something that like design science research, it is that we can already, let's say, how do we usually claim Newton's thing of we can already climb on the shoulders of
Giants.
Let's say, do something that we say, well, notice others have already used it. They thought it was sensible. The rest of the world thinks it's sensible, so I'll keep using it. But that should not prevent us from developing new methodological procedures when we think that they're convenient, that they are easier, and that they are also sound in the sense that people will agree with what we did.
Yeah. So one of the things we are thinking about doing right now is dropping the word design science from the paper, because
I would acknowledge you to do that. I would do that, because that may be a reason for gatekeepers to keep preventing your paper from being published, even when it has some great material there for everyone.
So we are just talking about, well, we designed an algorithm, and that's kind of where we are leaving it. We're not claiming design science, and we don't have design science theory. And because we have seen people would tell us, hey, go read the paper by Hefner and Greger in MIS Quarterly. First of all, most of those papers don't mean anything. You cannot really, like, the good designs are not necessarily formulaic. You cannot really standardize the process of product design. It's to some extent, it's unstructured, it's chaotic, and I think we our work should reflect that spirit. So we're still figuring out how to present this article for journals. We're working on it right now. Any other questions or comments from the group, from anyone else?
Feel free, guys. You know that we only have this kind of a special guest here once in a week, right? It's always on Wednesdays, and only on Wednesdays. So feel free to ask.
By the way, I also have my email address here. If anyone wants to have if you have a question that you want to talk with me later on, or you don't feel like asking publicly, feel free to reach out to me at any
Oh, that's nice.
I have a question, another question, sorry, but I'm taking advantage of the time. I'm doing a research with some mixed sources. One is the literature, kind of bibliometric analysis based on articles, research articles. But at the same time, I'm having interviews with government officials. It's about the smart cities. And there's a way to combine those two different sources, because I want to find out, for example, if the literature is doing the same that the officials want. So there's a way to combine both?
I am not sure. Well, the literature tells you what people have researched in the past. And what the officials will tell you is what they are doing currently. They are two different things, right? And in many cases, what we have seen is what research people do does not necessarily match with what people do in practice. There's a bit of a chasm between the two. And it's just the way it is. And, and so sometimes, I tend to focus more on practical problems, what people are actually doing and the problems they're facing, rather than what research people have done. Because if you notice that folks have not done it in the past, that gives you an opportunity to create a contribution. So I really enjoy it when there's a practical problem that no one has explored, right? That's an excellent area for doing research.
This is what we research was published in top journals about some applications, but we want to know if what they do fit those applications.
No, they don't have to. Again, as I say, people who do things that make sense to them, right? They necessarily will not do things because a certain theory or a certain paper said that they should do it. That's not the right way of looking at the world. You should do things that helps you, that works.
At the same time, no, maybe what she can do is use that theory that already exists as a reference to against which she will confront the data that she gets from her empirical work.
We did an ontology. Based on the literature we have, but we wanted to make a way to combine because it's too many sources. So that was the reason that automatizing was important, because reading all those articles, was coding. It was already done, but just comparing was the difficulty.
Yeah.
That's just a question. Thank you.
Do you think that it's going to be easy, or it's never easy?
Of course, it's not easy.
And it's good for our students, for graduate students that are still thinking about their first paper, right? Well, even after someone as experienced as Aurora is still being challenged by the research that she has ahead of her. All right. Any more questions, guys? Gee, you're shy today. I mean, I would expect Anol to be full of questions here, because I feel like starting using that methodology next week in my next project.
You left them speechless, Anol.
Well, feel free to ask questions that are totally unrelated to what I discussed. If you have some other questions about something else, you can ask them too.
The weather, perhaps?
Well, the weather is good in Tampa. Can't complain. We love Florida.
All right, let me see if we have we
Just
have a few people saying things in the chat. But yeah, go on, Guilherme.
Yeah, Violeta put one in the chat if you want to read it. I don't know. Let me see.
That's a good question of Violeta.
It's not a question. It's just I'm really happy to understand the difference in English of exploration and exploitation. As in Portuguese, it's the same word. So every time we try to translate a paper, we always mix the words, because for us it's the same thing. I mean, it's one word for both meanings.
So that is the reason why you should not use lexicon-based approaches in Portuguese, because you cannot capture the difference, right?
Yes, thank you. This was so great for me. I mean, it's so clear now.
Yeah. And Violeta, that's something that I think we'll have to figure out a way of introducing a new word in Portuguese, the same way as maybe Peter Drucker has done, for example, with efficiency and effectiveness. That used to mean the same and still mean the same for most people, but at least for us in business, we now think, one of them relates to productivity, the other one relates to one relates to doing something right, and the other one relates to doing the right thing, right?
Yes.
If we have to expand our vocabulary so that we can have better ideas in the future, because otherwise we are narrowed down by the vocabulary that we have. I also have the same problem. Of course, Portuguese is also my language here, and explaining to our students the difference between exploration and exploitation has always been a challenge, because we do not have those two words in Portuguese. And in fact, we have one only word that has all those different meanings. Even those different meanings that you have highlighted, for exploitation being exploiting someone in a negative way, but at the same time in being very efficient in collecting all what the resources are able to provide us with. Language helps us think new ideas, but sometimes it also blocks us from doing it.
Yeah, and I think fundamentally, if you look at what makes human beings unique is our use of the language. I don't think any other species has so much ability to understand language and communicate language and take language, write books with it, or make language into a TV series or a movie. This is kind of what makes us unique. Computation, I mean, computers are much superior to human beings in terms of adding numbers, subtracting numbers, doing accounts receivable, payables, etc. ERP systems. That's not really what we do. What we excel in is really human language, right? And that's sort of, I think, currently, if you look at AI, what we are trying to do is trying to teach computers how to understand languages. This is really one of the holy grails of AI, and along with
they seem to be learning fast.
Oh yes, they are. I mean, they are getting better, and it's scary. It's scary to the extent that GPT-3, so the GPT-3 is not available publicly. Microsoft kind of decided not to make it publicly available. GPT-2, the previous version, is available, which I use in my class. So they said that GPT-3 could be misused very widely. And I can exactly see why. So, I mean, I gave you an example. So if you're a high school student and your teacher gave you a writing assignment, write an essay on the American Civil War, and you have no idea, you don't care, you just go to a computer and generate a computerized report, and there you go.
Does that
I mean,
mean,
you can
Anol,
imagine that
that,
that's not nice, right?
yeah, does that mean that Microsoft wants to misuse it in a proprietary way?
Well, I'm not sure what Microsoft wants to do, but they kind of say that this is great potential of misuse. Not just misuse, and I mean, you could generate fake news articles that looks perfectly authentic, perfectly good. There is so many ways you can misuse, technologies. And so I think for valid reasons, down the road, you would see a lot of negative impacts of technology. And that is something you guys can think about in terms of research. A lot of times we kind of do research on technology use, acceptance, and all the productivity benefits of technology. But right now, what we are noticing, there are so many negative things, dysfunctional consequences of technology. Particularly on social media, you see a lot of dysfunctional behavior, spread of fake news, and artificial intelligence. There is biases in algorithm that people applying for loans, they get denied because the AI algorithm said, oh, you don't qualify for a loan, and no explanations, no nothing, and that is sad. Why do people get denied for loans, and why do they? Why do white people, not sentenced for the same offense the same way as a black person is? We have those racial problems here in America. And it's sort of historically persisted. And the way we train computers is by using data. So if you feed in all the 300 years of racially sort of discriminatory, examples of sentencing guidelines, and we feed it, we make the computer learn, it's going to actually learn all those negative things. And so if you have a white guy and a black guy who was apprehended for the same offense, it's going to say, well, let the white guy go, free, give him a fine, and take the black guy, put him in 10 years of prison. That makes no sense, right? It's the same crime. There should be, have the same whatever would be the fair consequence. But these kinds of things, people are kind of getting, we are waking up to these issues. And so there has been work on figuring out how can we build trust in AI algorithms, and how can we make them fair and they're accurate, and so forth. And so there's a lot of those kinds of research, particularly with technology and AI. I think it sort of opens up a totally new area of research that we did not quite have, like 5-10 years ago.
Yeah, for sure. IS as a research field will have to deal a lot more with ethical issues.
Yes.
Even more than that, with ethical issues, even with concerns that are, where do we want to go? I mean, we can solve any problems, but are those problems that we want to solve, or should we go a different track so that we preserve humanity?
Yes. Yeah, I think we have bigger problems in this universe right now. And I think the people who should study the problems should be us, right? Because we are the academics, we are trained researchers. And so there is no need for us to go study ERP systems anymore, because that makes no sense. ERP systems already work pretty well. So what we should study, we should study biases in AI algorithms. Maybe that would be an excellent thing to study. So those are opportunities, I think, for future young researchers trying to explore. And if you're interested in sort of having these discussions, just let me know.
We'll definitely have to invite you again next year, because it seems that you still have a lot to say to us.
Particularly if you have like a regular conference, I would like to physically go there and enjoy the company and the food. And I remember Santiago was one of my favorite places to visit, and I traveled north and south across Chile and Argentina. I went all the way, to what was the southern point in Chile? Punta Arenas.
Punta Arenas, yeah.
Yeah, Punta Arenas. So I went there, and I sort of traversed all the way through, the Andes mountains. I crossed the Andes at least 4 times. From Argentina to Chile and back to the Lake District, and going back and forth and back.
It doesn't count unless you did it walking.
That was my question. I was going to ask you if you have done that, as they say in Chile or Argentina, a dedo.
A dedo.
Because that's the way I did it.
I know in the olden days, the Inca, they run, right? I went to all their cities, and we traversed some of the Inca route and saw their cities, but they were.
Next year we have Peru. So Lima.
Yeah. Lima.
Really?
There's a chance that you can come to Latin America.
Yeah.
Which conference is that?
Well, we have the
ICF 9.4.
Yeah, I've been in Peru. I've taught a class in Peru. I have some really great students in Peru. Really nice, great people, and the food is really nice. And I would love to go there.
All right, guys. Aurora. Well, thank you very much for having organized this. Thank you very much, Anol, for being here with us, for sharing your ideas with this group. We're all very thankful to you.
Thank you.
Bravo.
Bye. Bravo.
Bravo.
You were fantastic. Thank you, Anol.
All right.
Thank you so much. It was great.
All right.
Another thing about Latin Americans, we are hard to say goodbye. We
never say goodbye.
But I am going because I have another class. It was great talking to you guys.
Thank you so much.
Thank you, everybody. Nice seeing you.
See you, Aurora.
Thank you, Anol.
See you soon.
Bye. Thank you, Anol.
Ciao.
Bye bye.
Bye.
Ciao.
Ciao, Guillermo. Ciao, Alexander.
See ya.